Hi everyone. So today we're going to go over lecture 19. So let's take a look at the first question. We're asked to graph the following and find the vertex, axis of symmetry, and the x and y intercepts. Our first example is the function f of x of 3 times x minus 2 squared plus 1. So let's go ahead and start solving that. So we know that we have a vertex form. So as you remember from lecture 18, there's a general form, which is ax squared plus bx plus c, and then we have vertex form as a function of x, where a times x minus h squared plus k is vertex form. When we are looking at a vertex form, we can pull out the vertex point straight from the equation. So let's go back to our first question and take a look at the vertex form. Remember that it's x minus h squared plus k, and when we pull out the point, it's just going to be h and k. So let's go ahead and look at our first example. So we have 3 times, we have f of x equal to 3 times x minus 2 squared plus 1. And we're asked to find the vertex, which is a point, right? And remember, it's minus h, right? The vertex form is a times x minus h squared plus k, and our point is hk. So here, it's already in vertex form. I see my h right here, and I see my k right here. So I know that my point, my vertex, is 2, 1. Now let's take a look at the x-intercept. I know I have x-intercept when y equals 0, so what I have to do is I have to set this equal to y and to 0 and solve. So we have 3 times x minus 2 squared plus 1 equals 0. So we're going to subtract 1 on both sides. Right? I got to get rid of this multiplying 3, so I'm going to divide it out. We have x minus 2 squared equal negative 1/3. Got to get rid of this exponent, so I'm going to take the square root of it on both sides. Okay, now I notice that I can't keep solving here because I ran into a problem because I have a negative radicand and an even index. So I know that this is going to give me an imaginary solution. So therefore there is no x-intercept. Right? Because when we have an imaginary solution, the graph does not hit the x-axis, right? We don't have real roots. So now let's take a look at our y-intercept. All right, we have a y-intercept when x equals 0. So what we have to do is we have to plug 0 for any x variable you see. So we have 3 times 0 minus 2 squared plus 1. So that's 3 times negative 2 squared plus 1. 2 squared is 4. 4 times 3 is 12. Plus 1 is 13. So here's my y-intercept. I like to use the point. So 0, 13 is my y-intercept. Alright, and we also have to find the axis of symmetry. So let's go ahead and find that too. Okay. So the axis of symmetry is a line through a shape so that each side is a mirror image, so that both sides are symmetrical. It splits the graph into two halves that match up. That is what the axis of symmetry is. Alright, so now let's go ahead and find the axis of symmetry. So I'm going to go ahead and erase this. And I'm just going to rewrite what we found. So we found that the vertex was 2, 1. We found that there was no x-intercept. And our y-intercept was 0, 13. And now we're going to find our axis of symmetry, which is just a line that runs through the x-axis. So our axis of symmetry is going to be in the form of x equals a value. Okay. So here we have to find the axis of symmetry. Okay, and now that's given by the formula where x equals negative b over 2a. As you notice, it's also how to find the vertex, right? This is the same formula we used to find the vertex, right? We would use this to get the x value, then we would take it and plug it into our function to get the y value, right? To get the vertex point. But we're also going to use the same formula to find the axis of symmetry, because the axis of symmetry is what splits the graph in half. So for example, if you have a graph like so, okay, the axis of symmetry is going to be it goes through your x value of your vertex, right? Since your vertex is the highest and the lowest point of your graph, right? A vertex is the highest or the lowest point of your graph. That's why you're using the same formula, because the axis of symmetry goes through that highest maximum or minimum point at the x value. So let's find the axis of symmetry. So I'm going to go ahead and plug in some values. So first I'm going to label my A. But since we already found, we don't even have to do this, because since we already found the vertex, right, I know that the axis of symmetry is just the x value of my vertex. So I know that the axis of symmetry for this equation is x equals 2. Right? Since I already solved for my vertex, and I know that the axis of symmetry is the x value of my vertex, I can go ahead and claim that the axis of symmetry for this function is equal to 2. So now let's go ahead and graph it. So let's go over some things before we graph. Let's take a look at our function again. Our function is in vertex form. That's why we were able to pull out the vertex right away. We tried to find an x-intercept by setting it equal to 0 and solving, but we we ran into a problem where we had a negative radicand and an even index, so we couldn't, so I knew there were no x-intercepts because it was imaginary solution and it would not cross the x-axis. Then for our y-intercept, we know that we have a y-intercept when x equals 0, so what we did is we substituted 0 for our x values and we got 13. Then for our axis of symmetry, we have to use the formula of negative b over 2a, which is the same formula we used for the vertex to get our x value. And since we already did that, we already have our x value for our vertex, I know that the axis of symmetry equals 2. So now we have to graph it. So let's go ahead and graph. Okay. Okay, so here's our graph. My equation is 3 times x minus 2 raised to the second power plus 1. There we go. Okay, so here's our graph. Let's zoom in. Okay. All right. So as you can see, our graph of this function does not cross the x-axis, hence no x-intercept because we have imaginary roots. Then we have our y-intercept, which is right here at 0, 13, our point. And then we also have the axis of symmetry, right? Our vertex here is 2, 1. And then we also have our axis of symmetry, which is right here at x equals 2. Oh, can't really move it that much. No. No. What is this? What is happening right now? Okay. So here is our axis of symmetry at the line x equals 2. You see how the axis of symmetry splits the graph in half? Hence symmetrical, makes two sides symmetrical. As you can see, our axis of symmetry goes through our vertex. So since it's going through our vertex, it's going through that point at x equals 2. Okay, let's move on. So now let's take a look at letter B. We have the function of f of x equals x squared minus 6x plus 5. So again, we need to find the vertex, the axis of symmetry, and the x and y intercept. So let's go ahead and do that.